Good morning, ladies and gentlemen, or good evening, whatever the case may be. We are going to do, believe it or not, Unit 10, Lesson 2, Video number 3. So in this particular video, we're going to look at a special type of problem. This particular problem is indeed a problem of this nature, is indeed on your assignment that you will be doing Friday. In the previous two videos over Unit 10, Lesson 2, were somewhat entailed, so we needed to make a third video to go over these examples here. And we're considering reviewing the last two lessons, Unit 10, Lesson 1 and Unit 10, Lesson 2 next week, just as a review, because this has been some tough stuff here. So let's look at this type of problem here. This is an unusual type of problem, and this is going to use the sum and difference formulas for cosine. The first thing I need to realize is that this guy right here, the inverse sine of 3/5, A is an angle, and the inverse cosine of 3/5, B is an angle. These guys are angles because the output of inverse sine and the output of inverse cosine are angles. So right away, what I'm going to do is I'm going to come over here and say, hey, what do I want? I want the cosine of A minus B, where A is equal to inverse sine of 3/5, and B is equal to inverse cosine of 3/5. And if I say that, now I want to use the difference formula for cosine, and we can go back and review that. We have it in our notes, and you'll see that I have this. I'm going to go back to the original document here, which gives us the inverse cosine for the difference of an angle right here. And this is what we're going to use. The cosine of A minus B is cosine A, cosine B, plus, right there, remember, sine A, sine B. So let's go back to this particular example we were doing. Okay, we're going to go back to the bottom. So this is going to be cosine A, cosine B, plus sine of A, sine of B. Well, what we need to do now is we need to figure out what the sine of A is, what the sine of B, and cosine of A and cosine of B. Well, here's what we know. True or false, if A is equal to the inverse sine of 3/5, and if I sine both sides, then the sine of A, hello neighbor, is equal to 3/5. That's very nice. So now I have this guy right here is 3/5. Nice. Okay. And I also know, let me extend the page here a little bit, scroll back up a tick. I also know that if B is the inverse cosine, of 3/5, and the cosine of B is equal to 3/5. And so right here, this guy here is going to be 3/5. What I need to figure out is what the cosine of A is and the sine of B. And what I'm going to do is and this is a trick that I don't know if it's a trick, it's a strategy that we use in calculus all the time. We're going to take this statement right here, and we're going to create a right triangle. And keep in mind, ladies and gentlemen, boy, that's a horrible right triangle. It's a horrible straight line. Well, it's a straight line, but it's not quite. I think I deleted the wrong thing there. I did. Can't get that thing deleted. There it goes. Okay, so now I'm going to try another. I'm going to go wet. There we go. Whoop. Then right there. And this is, like I said, a strategy that we use a lot in calculus. And I'm going to let this angle right here be A. And I'm going to use the fact that the sine of A is 3/5. Well, if the sine of A is 3/5, by the geometric definitions of the trigonometric ratios, the sine is the opposite over the hypotenuse. And you can see, right away, 3, 4, 5 is the most common Pythagorean triple. And this triangle right here, true or false, this tells me that the cosine of A is equal to 4/5. So guess what? The cosine of A comes up here to 4/5. That's where that guy goes. In like manner, I'm going to create a triangle for this guy right here. This one's going to be a little bit higher. And where this angle right here is B. And I know by my geometric definition of trigonometric ratios that the cosine is the adjacent leg over the hypotenuse. This, of course, is a right triangle. And there again, this is the most common Pythagorean triple. And I use this common Pythagorean triple so that we can get to the answer nice, and their mathematics isn't that difficult. And so, hey, what's the sine of B? Well, the sine of B has to be 4/5. Opposite over hypotenuse. So right here, this goes to 4/5. So in the original question, keep in mind, what did we want? We wanted to know what the cosine of inverse sine of 3/5 minus inverse cosine of 3/5. Well, it's going to equal this. This tells me the sine of A is B. Cosine of B, sine of A is 3/5. Cosine of B is 3/5. And now what does this equal? I'm simply going to multiply those together. This is 12/25 plus 12/25, and that is equal to 24/25. Okay? Let's do a bit of a more advanced type of problem using the same method. And here we go. Okay, so again, I have the cosine of inverse tangent of 5/12 and the inverse tangent, or the inverse sine of 3/7. So, okay, we're going to use the same strategy that we used before, and we're going to let that be angle A, and it is going to be an angle because the inverse of any trigonometric function outputs an angle. So this A is an angle. In like manner, I'm going to take over here, I'm going to say B is equal to this angle. Again, these are angles. So what do I want? What I really want then is the cosine of A plus B. And you'll have to find a blank page in your interactive notebook to write a copy of these problems down so you can take a picture and post it. Okay. All righty. So this is actually going to look exactly like the problem that's on the assignment. Or whoop. Okay. This problem here is going to look exactly like this problem. Okay, hey, so what's the cosine of A, cosine of B? Cosine of A plus B, that's going to equal cosine of A, cosine of B. Oh, is it plus or minus? Oh, is it plus or minus? Well, let's go back to the original and look. Oh, if I'm adding, if it's cosine of A plus B, it's cosine A, cosine B minus sine A, sine B. Okay, just to verify, just to make sure that we're on the right page, and you're allowed to go back. So we're going to use the cosine of A plus B, this guy right here, is cosine A, cosine B minus sine A, sine B. That's the one that we're going to use. We're going to come back down here to this particular problem we are working on. here. And so cosine of A plus B is cosine of A, cosine of B minus sine of A, sine of B. And so what do we need? We need these values right here. We need these values in here. Oh, okay. So now I'm going to take this rascal right here. And if A is inverse tangent of 5/12, what do I know? I know that by the geometric definitions of the trigonometric ratios, the tangent of A is equal to, that's kind of freaky. Let me clear that out. The tangent of A is equal to 5/12. Okay, and this is going to be my angle A, as I did before. And I know that geometric definition, the trigonometric ratios, the tangent is the opposite leg over the adjacent leg. I also know if I were going to find this missing value here, that 5, 12, 13 is a Pythagorean triple. And you can use the Pythagorean theorem to find K, because K is going to be the square root of 144 plus 25, and that's going to give you 13. So this guy is 13. And so what do you want? You're going to need the sine of A and the cosine of A. And we know that is the sine of A is equal to 5/13. The cosine of A is equal to 12/13. And that's going to go in here, up here, for the cosine of A and sine of A over here. Whoops, what are you doing? What are you doing? Get back here. Get back here. Sorry, that kind of is freaky. Okay, so the sine of A is 5/13. We're going to put that here. And the cosine of A is 12/13. And what I need now, the cosine of B and the sine of B. And what do I know? If I scroll up here just a little bit, I know that this B is the inverse sine of 3/7, so true or false, it's going to be true that the sine of B is going to equal 3/7. This is going to be our angle B. By the geometric definitions, I'm going to label this triangle. This is going to be the opposite over hypotenuse. And now this is not a Pythagorean triple. So I'm going to have to find K this time. And I do know, ladies and gentlemen, that K squared plus 3 squared is equal to 7 squared. Therefore, K squared, this is 49 minus 9 is 40. Hello, neighbor. K is going to equal the square root of 40. You can simplify this radical expression, this square root, if you want. But you know what? I'm just going to leave it square root of 40 because I feel like it. And so now I already have the sine of B. What do I need? The cosine of B. And what is the cosine of B? The cosine of B is going to be the square root of 40 over 7. And I have to admit, these Smart Notebook notes, they get all jumbled up because we don't have a big expansive area to write, but I think we're okay. So I'm going to put this guy in for cosine of B. It's going to be square root of 40 over 7. And the sine of B, we know, is 3/7. And guess what? You know what I would like to do? I'm going to just leave this like it is. I have this product minus this product. And right here, if you get that far, you're going to say, good deal, good enough. So there is going to be a problem similar to this problem on the assignment. It's going to be similar to this rascal right here. This is just an application of what we did last week and an application of this particular sum formula for cosine. So I will bid you good day and see you later.